You are looking at a wall of concrete, 726 feet tall. Behind it, 1.4 quadrillion gallons of water. That number is almost impossible to process. 1.4 quadrillion, enough to flood all of Texas 6 feet deep. This is Hoover Dam, and the story of how it got built will wreck your sense of what's possible. But here's what nobody saw coming. The men who built it didn't fully understand if it would even hold. The concrete alone generates its own heat, enough heat, if poured wrong, to crack the entire structure from inside. And yet here it stands, 90 years later, holding back the Colorado River every single day. But the science of containing a river wasn't even the first problem. The Colorado River was a killer. Floods in 1905 nearly destroyed an entire region of Southern California. By the 1920s, 7 states, Arizona, California, Nevada, Utah, Colorado, Wyoming, and New Mexico, were fighting over the water. The Colorado River Compact was signed in 1922. It divided the river's flow between upper and lower basin states. But dividing water on paper means nothing without something physical to control the river. The Bureau of Reclamation surveyed the canyon walls for years. Black Canyon, on the Nevada-Arizona border, was chosen in 1928. The canyon walls were hard volcanic basalt. The river ran fast, nearly 300,000 cubic feet per second in flood season. Congress passed the Boulder Canyon Project Act, December 21, 1928. Funding approved, $49 million. That's roughly $800 million in today's dollars. And they expected it done in 7 years. But nobody had ever built anything like this, not even close. Then everything changed. The moment construction actually began. 6 companies incorporated won the contract in 1931. It was a consortium of the largest construction firms in America. The workforce descended on Black Canyon almost immediately. At peak construction, over 5,000 men worked the site daily. Las Vegas in 1931 had a population of 5,000 people total. The dam project nearly doubled the region's population overnight. Workers lived in Boulder City, a government-built town, purpose-made, constructed from nothing in the Nevada desert. Summer temperatures at the canyon floor hit 130 degrees. The rock walls absorbed heat and radiated it back through the night. 96 workers died during construction. Some from heat, some from blasting accidents, some from carbon monoxide in the tunnels. Watch what the engineers did before a single concrete pour began. First, they had to move the river. You cannot build a dam in a river that is still flowing. 4 diversion tunnels were drilled through the canyon walls. Each tunnel, 56 feet in diameter, wide enough to drive a semi-truck through. Total tunnel length, over 3 miles. Workers drilled and blasted through solid rock for 18 months straight. The drilling rigs were mounted on trucks, called jumbo drills, carrying 30 rock drills each, attacking the tunnel face simultaneously. By November 1932, the Colorado River was fully diverted. The riverbed, dry for the first time in geological memory, stood exposed. And then the real problem started. The riverbed was not solid. Underneath the gravel and silt, 80 feet of unstable alluvial material, all of it had to go. Every single cubic yard, removed before any foundation work could begin. Workers excavated down to bedrock, pure, uncracked volcanic rock, 135 feet below the original river surface. Excavators removed over 1 million cubic yards of material. Nothing could remain, not a pebble of loose stone. The canyon walls also needed surgery. High scalers, workers dangling on ropes hundreds of feet up, chipped loose rock by hand. They worked from Bosun chairs, swinging on ropes, using jackhammers and pry bars against sheer vertical walls. Loose rock falling onto the dam base would have created fracture points. Every wall had to be clean, solid, bonded. Here's the crazy part. The concrete itself nearly destroyed everything. Concrete generates heat as it cures. This is basic chemistry. But Hoover Dam wasn't basic. It was 4 million cubic yards of concrete. If poured as a single mass, the curing heat would have taken 125 years to fully dissipate. The thermal expansion and contraction would have cracked the dam beyond repair. Engineers had never faced this problem at this scale before. The solution was radical. Pour the dam in individual columns, 230 rectangular columns, each poured separately, each allowed to cool. Inside each column, engineers embedded 1-inch steel pipes in a grid. Cold river water was pumped through those pipes continuously. The system removed heat from the concrete as it cured, actively cooling each column from the inside out. 35 miles of cooling pipe ran through the dam's interior. After cooling, the pipes were pressure-filled with grout and sealed permanently. They exist inside the dam to this day, still there, sealed in concrete, 90 years underground. What they discovered next forced a change nobody had planned for. Even with the cooling system, the columns had to be bonded together, poured separately, but they needed to act as one unified structure. Engineers used a shear key system, interlocking grooves cut between columns. Like puzzle pieces, each column locked into the ones beside it. Grout was pressure injected into every joint under high force. Every gap, every seam, filled, bonded, sealed. The result, a monolithic arch gravity dam. Two structural systems working simultaneously. Arch action and dead weight. The arch shape pushes outward against the canyon walls. The shear mass, 6.6 million tons, pushes straight down, both forces working together, transferring load to the bedrock foundation. Neither system could hold alone. Together, they hold everything. Notice how the dam actually curves when viewed from above. That curve is not aesthetic, it is load engineering at massive scale. The upstream face is nearly vertical, almost a straight drop. The downstream face angles outward, widening from 45 feet at the crest to 660 feet thick at the base. Every dimension was calculated to resist the pressure of Lake Mead. Water at that depth exerts 45,000 pounds per square foot at the base. But the structure wasn't the only challenge, not even close. Lake Mead, the reservoir behind the dam, covers 247 square miles. It holds enough water to cover all of Pennsylvania 1 foot deep. That volume of water weighs over 1 trillion pounds. The weight of the lake itself depresses the Earth's crust measurably. Geologists detected microseismic activity as Lake Mead filled for the first time. The ground was adjusting to a load it had never carried. Filling began in 1935. And it took 6 years to reach full capacity. 6 years of pressure building, inch by inch against that concrete wall. Here's where it gets impossible. The dam contains 2 power plants, one on each bank of the canyon. 17 turbine generator units produce up to 2,080 megawatts. That is enough electricity to power 1.3 million homes. Nevada, Arizona, and California all draw power from Hoover Dam today. The generators were installed during construction itself. The first unit came online in September 1936, before the dam was even officially dedicated. 4 intake towers stand in Lake Mead, 4 of them each 30 feet across. They draw water from multiple depths, allowing temperature and flow control. Water drops through penstocks, steel pipes 8 to 13 feet wide, 400 feet down to the turbines below. The velocity of water entering the turbines reaches over 100 feet per second. That kinetic force spins generators weighing over 2 million pounds each. Then something hit that nobody had anticipated, and it nearly tore the tunnels apart. In 1941, one of the original diversion tunnels, now repurposed as a bypass, began showing signs of catastrophic damage. Cavitation, water moving so fast it creates vapor bubbles, was eating through concrete and into solid rock. Engineers pulled back the lining and found a hole 37 feet deep. The rock behind the concrete had been consumed, hollowed out by force alone. No explosion, no blasting, pure hydraulics, water pressure, moving fast. 3,000 cubic feet of concrete and rock, simply gone. 5 miles away, the tunnel was repaired with high-density concrete. Aerators were installed to inject air into the water flow, killing the bubble formation. The fix has held for over 80 years, but it changed how engineers designed every high-velocity tunnel built after that. Watch what the finishing of this structure actually required. The dam was dedicated on September 30th, 1935, by President Franklin D. Roosevelt. It was completed 2 years ahead of schedule, 2 years early, on a project nobody had ever attempted before. The entire American engineering establishment had called the schedule optimistic. Over 21,000 workers were employed during the project's full run. Total concrete poured, 4,400,000 cubic yards. The crest of the dam is 1,244 feet wide. You can drive across it on US Route 93, 2 lanes, straight across the top. The road along the crest was public until 2010. After a bypass bridge opened that year, the dam road became pedestrian only. The Mike O'Callahan, Pat Tillman Memorial Bridge now carries highway traffic. It spans the canyon 900 feet above the river, the longest arch bridge in the Western Hemisphere. Look at the scale from that bridge. Just look, the dam drops away below you, and it still looks almost unreal. And what it left behind changed an entire continent. Lake Mead transformed the American Southwest. Before Hoover Dam, the Colorado River flooded unpredictably, then ran dry. Farmers downstream in California's Imperial Valley had no reliable water supply. The entire agricultural economy of the region was at risk. After the dam, 2 million acres of farmland were guaranteed a steady supply. Imperial Valley became one of the most productive agricultural regions on Earth. Las Vegas, 5,000 people in 1931, is now 2.2 million. Every major casino on the Strip runs on Hoover Dam power. The dam also proved something bigger than one project. It proved that federal infrastructure investment could reshape geography itself. 14 dams followed on the Colorado River system within 30 years. Glen Canyon Dam, Parker Dam, Davis Dam, a whole cascade of concrete and water control. But here's what still stands out. 90 years later, Hoover Dam was inspected extensively in 2015 by the Bureau of Reclamation. The finding: the structure remains in excellent condition. 6.6 million tons of concrete, poured starting in 1931, still holding, still generating, still managing the river. The cooling pipes sealed inside the dam, never removed, never accessed. They are just there, locked in concrete, doing nothing, going nowhere. The high scalers who dangled on ropes above Black Canyon, their work, removing loose rock by hand, is still holding the walls clean. Every calculation made without computers, done by hand, on paper, with slide rules, every single one of them correct enough to hold 1 quadrillion gallons. Right there, in that canyon, is the answer to what human engineering can do. When the stakes are high enough and there is no option to fail, the next impossible build is already starting. Subscribe to Built Impossible